yeah, it is freely available, so you will be able to download the software and use it as well. You don't have to worry about anything else. So Helen, I'm making you, I want to make you, what's the word?
Host?
Yes.
Okay, please.
So for today, I want to show you a few things. Of course, there is a lot and we can't handle it today, but for today, I've prepared a simple outline. I'm going to show you how we can download satellite imagery that is freely available. And then we shall dive into quantum GIS, and then we do a spatial subset. We do image mosaicing, we create color composites, and then finally for the day, we shall do supervised and unsupervised classification. So just a simple background. In the modern world today, we have a lot of freely satellite imagery, such as Landsat, MODIS, Sentinel, and so, but each person uses this data in their own way. So it's up to the individual who is using the data to decide on how to access that data. So there are various ways in which you can access that data. You can download it directly from their websites, or you can download it using an API or a third-party provider. So on this slide, I have some of the platforms you can use to download You can use to download the freely available satellite imagery. So as you see this one, I hope you can see my cursor. This one is USGS, GLOVIS. You can also use another, for GLOVIS, you can download Landsat 8, Sentinel-2, and many other data sources. The same applies to, for Copernicus, you can only download Sentinel products. And then there is another interesting one here, QGIS. QGIS is a third-party provider that you can use to download all these freely available data sources. And then we also have the Earth Explorer. So it's up to the individual who is going to use this data on to decide what would you want to download your data from. So me personally, I prefer using GLOVIS. So today I'm going to take you through how to download data using GLOVIS. So you just have to simply type in your search browser GLOVIS, and then you'll see this this domain glovis.usgs.gov. Let me hope I'm not fast. Sorry, let me hope I'm not fast.
We are not seeing your screen though, apart from the slides.
Oh, okay, sorry. Let me demonstrate once again. Can you see my screen now?
Yes, we can.
Thank you. So I'm sorry. So you just type in GLOVIS in your search bar, and then you'll see this address, glovis.usgs.gov. And then you can open this this link. So when you open it, ideally you have to register if you don't have an account. So if you don't have an account, you have to register. But since I have an account, I'll just log in into my account. And then I do it, I will sign in. Yeah. If you don't have an account, you just click here and then you register. It is a very simple process. Yeah. So I'll continue as Jesse. So when I continue as Jesse, I'll launch it in full screen mode. So when you open GLOVIS, it will open for you a new window like this. So at your disposal. You can get any satellite imagery available within this database using this platform. So it's up to you to define a geographical area, the imagery type, the date, and what exactly you want to download from this data source. So if you look here, this is where you select the data you want. As you see, you can download Hyperion, you can download Global Land Survey, you can download Landsat 1 to 5, Landsat 4 to 5, thematic mapper, you can download Landsat 8, and further you have Sentinel-2 and other data sources. So it's up to you to come and then select whatever you want. And then here we have a metadata filter. So for this metadata filter, you can use it to select the date, and then the cloud cover, and then the month if you want. So let me demonstrate by trying to download Sentinel-2. So I will click this, Sentinel-2. When I click Sentinel-2, I need to define my geographical extent of the data. So I will use my mouse to zoom in here to Uganda. And then let me just select an area around Buyungo here where we know Mabira Forest. So like a place like this. So immediately I select this, the algorithm will load for me a number of scenes. But for me, I may have a specific data range that I'm interested in. Let me say I want to select data from January 2021 to December. So I will use this date range from, the date will be from January 1st, the year is 2021, and then let me stop in December, still 2021. So 31st December is 12, then 2021. Then I do what? I apply. So when I click apply, so as you see here in this, can you see my mouse?
Yes, we can.
Thank you. So if you can see my mouse, sorry. Moment. Let me refresh it. So yeah, I was interested in Sentinel-2, and specifically I was downloading it here around Mabira. So that is where I had placed my my point. So this is the date, and then I will apply. So of course, depending on how fast your internet is, it will give you results. But because I don't have a very stable internet connection, let me just use a query of 1 month. No, the results are here. So as you see this panel down here, this is where you'll see the results of your query. So you can, if you've selected the number of years, you can use this year. But if you've selected the data in monthly ranges, so you can click on the on the month, and then each yellow dot represents data in a given month. So if you've selected a small scale, maybe days, so you can select this this day. So hope that is fine. And then the beauty with this image or this platform is that whatever image you select, you can preview it, and then you can be actually able to see the cloud cover and other parameters that you can usually see on the on the select imagery. So further, you can select a scene, and then you click this view metadata. So when I click the view metadata, I can be able to see the attributes of this image. What is the cloud cover percentage? When was it recorded? how many bands are available, and other types of what? Of data. Oh, let me see. So I hope you can see this metadata. So as you see, we have the acquisition date, the start date, and then the end date. We have the tile number, we have the cloud cover, we have the agency, the platform, and other what? Other features. So further, that this cloud cover is too much, so I can choose to further filter my results using a what? A cloud cover filter. So let me say I'm interested in imagery that doesn't have a lot of cloud cover. So I can choose to filter between 0 to 10%. Hope you see this what? This filter here. And then you just click apply. So when you click apply, as you can see here, it is processing, and then it is telling me 46 scenes match your search what? Criteria. So after this algorithm has finished showing me my results, now it's up to me to decide on what to download and what not to what to download. Maybe I'm interested in data that was collected in May. I'll just go into that data and then I just download that. I hope that is fine. So my results are here. I can select one result around moment. Select this. So if I've selected that product, and then I'm very contented of what is on that product, and then I want to download this product for my further processing, I just come here and I click what? Download. But remember, this download option will only be available if you have registered to use this what? This service. I hope that is fine. Yeah, and now it's time to, yes, please, yes, please.
So the image you're downloading, is it with metadata or without metadata? What it shows?
So when you click that download button, you have two options here. If you download the first one, because now I'm dealing with Sentinel-2, if you download this first one, it will be a complete file. It has everything inside. There is metadata, there are bands, and then there are other what? Features inside. But if you just download this GeoTIFF format, it's just a very light satellite imagery. Actually, you can't even use it for what? For remote sensing application. Maybe you just want to look at it outside this platform, you can download this. But if you download this, the first product, it will have the metadata. Have I answered your question?
Yes, you have. There's someone with who has raised a hand. Angela.
Okay.
Yes, Jesse, I wanted to ask.
Yes, please, Angela.
In case you want to specify the resolution for your image, does this software give you that opportunity to specify the resolution that you want, or you just download?
Oh, yes and no. Yes, because remember when we know that Sentinel-2 is 10-meter resolution. Then the moment you select Sentinel-2, that means you'll have imagery of a 10-meter resolution. If you select Landsat 8, you've already selected your what? Your 30-meter resolution. If you select, let me say Hyperion, remember Hyperion is very high resolution. That means you've specified to download high resolution what? Data. Have I answered you?
Yes, thank you.
Thank you. Should we continue?
Yes, please.
Okay, thank you. So I would recommend you to have like a third-party what download manager like IDM, because sometimes this process is very slow and it is okay. It's not that confusing, but it sometimes gets slow. So in order to make it faster, you may need to have a what? A third-party internet download manager. So once you finish that, you will download something like this. Let me share this too. Can you see my screen, please?
Yes, we can see it, the folders.
Thank you. So once you finish downloading, you'll have something like this. You see this compressed file? It is extract. So this is S2A, means Sentinel-2A, operational multispectral imager. So it is LC1 data, L1C data collected on the 1st of January 2016. So then I'll of course unzip it, and then when you unzip it, inside here there are multiple products. So if you want to have a look at the image array, you'll just come here to the granule, and then inside the granule, you'll enter inside another folder. Is a folder called image data. So, but of course, each satellite will have its own format and how they store their data. For example, if it's Landsat 8, they'll have a different format of organizing their data in each subfolder. If you've downloaded Landsat 7, it will be a different format. So it's up to you to go on and study and know how each satellite or each sensor organizes what? Its data. So as you can see here, these are Sentinel-2 bands. So this is Sentinel-2A, operational multispectral imager, L1C data, but it's band 01, as you see. Band 01, this is band 02, band 03, band 04, band 05, up to band 12. So it's up to the user to know and study what is the meaning of band 1, which band is band 2, which band is band 3, which band is band 4, such that by the time you come here to use this data, you already have that in what? In mind. I hope that is fine. So let me demonstrate this once more. Sometimes it is confusing. You may look for this data and you can't see it. So once you unzip it for Sentinel-2, you enter inside, then the granule, you open inside this folder, and then you'll have image data. And then that is your what? Your Sentinel-2 bands. I hope that is fine. So after this step, I would love to dive direct into our what? Our practical session where we are going to play around with this data. Maybe if there is any question, I can take it, but if there is no question, we can proceed to QGIS. Okay, cannot see any question. So as QGIS is loading, maybe let me tell you a little bit about QGIS. I just like QGIS because it is open source and you don't need to crack it. You just install it and then use it. And when using it, you don't have to crack anything. Everything is available. You just have to drag it and use it and then leave it the way it is. I'm not against other softwares or other producers of GIS softwares, but I just love QGIS. Yeah. Moment. So this is my QGIS. I mean, I've opened it. So for remote sensing application, the first thing that you have to do is to install a plugin that is going to help you to perform those what? Those applications. So for this process, you need at least some internet connection. So you'll come here to plugins, then manage and install plugins. And then when you click manage and install plugins, it will open for you the repository for QGIS plugins. And then you'll just come here and search SCP. So when you search SCP, two options will come up, and then you'll install the semi-automatic classification plugin, this one. So you just click it, and then there is an installation button here, then you install it. And after that, you just have to close it and then proceed to do your remote sensing applications. Yeah, so the first thing that I'm going to do is that I'm going to import this image into the software. So I'll go to layer, add layer, then add raster layer. When I go to add raster layer, I will browse to where I'll browse to this to this directory where I have my my data. So I'll click this, and then come here. Then here, then image data. So for this tutorial, I'm going to import the first 4 bands only. Yeah, to make it a smooth process. So I will import band 1, band 2, band 3, and band 4. So remember, the band 1 for Sentinel-2 is coastal aerosols, and then we have the blue, the green, and then the red. So those are the only 4 bands I've imported. Yeah, so as you see here, I have band 1, band 2, band 3, and band 4. So band 1 is the coastal aerosol, then band 2 is the blue band, band 3 is the green band, and then band 4 is the red band. So that's what we are going to work with today. Yeah. So after installing that plugin, you'll have an option here is SCP. So I'll dive directly into the tutorial. So I'll click SCP, and then I'll click this this band set. When I click this band set, it will open for me this plugin. And with this plugin, I can do a lot of things concerned with remote sensing, what we've covered in class and what we have not covered in class. So here are a number of tools. So you can have basic tools, as you can see here. You can export signatures, you can import signatures, you can have pre-processing options for different satellites, Sentinel-1, Sentinel-2, Sentinel-3. You can mosaic bands, you can project rasters, and then you can come and post-process your data after classification. You can come here and do classification. So with this plugin, we can do a lot of things. So it is again up to the user to determine what do I want to use this plugin for, and then you continue. So the first thing that I always do is to refresh this plugin. When I refresh this plugin, I can be able, this is the refresh button, and then I also refresh here. So when I refresh this one, my plugin will automatically capture the data that I have imported here. So as you see, I have band 1, band 2, band 3, and band 4 here. So the different bands, as you can see them. So yeah, but since this data is very big and we don't have that much time, I'm going to create a spatial subset. I'm going to clip out a study area that we can use for our tutorial. So to do that, I will come here to pre-processing, still in this plugin, and then I'll come here to clip multiple rasters. Let me repeat it once again. Yeah. So you see band 1, band 2, band 3, and band 4. So you select band 1, band 2, band 3, band 4, and then you add them to this to this band set 1. I've not shown you this. So you add them to this band set 1. If you've selected a band you don't want to use, you can select it and remove it. Or you can select all the bands and remove them at once. So, but for me, I want to use all these bands, band 1, band 2, band 3, and band 4. So I will add them. So when I add them, there are a number of options here. So we have wavelength, quick settings. So me, I'll use the band order as the way the bands are ordered. If I had all my data here, like from band 1 to the last band, I'll just come here and I select maybe Sentinel-2, wait, Sentinel-2. Yeah, like this. But since I don't have all the bands, I'll just come and I select band order. And then, yeah, for the wavelength, I can use a micrometer. Yeah, and then that. So after there, I'll come to what? To clip multiple rasters. Remember, we have different rasters. We have band 1, band 2, band 3, and band 4. Now I want to clip them such that we can get an area we can work with. So there are two options available. So the first thing is select the input band set. It is band 1. Of course, the no data value is 0. So for clipping, you can use a vector data or you can show the area on the map. Since I don't have my vector data here, I will click this and then I come here and then I select an area here. You just have to play around with the left click and the right click of your mouse. The left click will make the what? No, the left click and the right click. One will increase it in the upper diagonal and then one in the lower what? The lower diagonal, as you can see. So let me just take that area. So I've selected that area. And then after there, I'll click this run. So when I click run, the software will prompt me to select where I want to save this data on my computer. So I will browse back. And then I'll create here a new folder and then I call it clip. Then I'll select it and then I say select folder. And then immediately I select folder, the software will run. So as you can see here, I can even track the progress from this semi-automatic what? Classification toolbar. And then within a few minutes, I'm done. So I no longer need this data, this data, this data, this data. I'm going to remove it. And then I will remain with what? With a smaller area. Is there any question before we proceed?
Yes, sir.
Thank you.
Kindly go back to the clipping part of it. I've not gotten it well.
Okay.
Yeah.
Did you get here? This step here on how you select your bands. Let me first clear. Let me clear this. So if now that I've removed them, I'm going to work with the clipped data. So I have 4 clipped bands, band 1, band 2, band 3, band 4. If I want to clip all of them at once, I will add them to a band set here, like this. Then when I add them to a band set, of course, I'll select a band order and the wavelength. Then after that, I will click this option, pre-processing. Under pre-processing, we have click multiple rasters. When you come here to click multiple rasters, the first question will be select your input band set. Of course, here we have one band set. We've not created another one. So it will be 1. And then the no data value will be 0. The output prefix, I can use clip or any other you want. Then for the options to use for clipping, we have 2. You can use a vector for clipping, but then I've not imported any vector. So what I'm going to do is that I'm going to click this plus button, and then I select my area on my what? On my layout like this. And immediately I select it like this, like this, like this. And immediately I select it, you'll see that these coordinates will keep changing. And then after, I will run. So when I run, the algorithm will request me for a folder to save the data. And then when I select the folder, it will automatically run. Are we at the same pace?
Yes, please.
Thank you. So at this step, I want to, I've finished clipping, and then I just want to stack my what? My data. So to do that, I will still come to the SCP plugin, and then I open this band set. So I'll refresh it to capture whatever I have. Then I can clear this and then re-add my data. So when I add my data, I will click, you see this, create a raster of band. You see this, stack the bands. I just tick it and then I run. So when I run, it will still prompt me to select where I want to save the what? The stack. So I'll create a new folder and then I call it stack. Then I'll select it and then automatically it will do what? It will run. And then as soon as it finishes running, it will prompt me that, you know what? I've finished running. So let me show you the product. This down, this down, this down. So this is what I've managed to stack. And of course, as you look at it, it doesn't make sense here. So I just want to take us to the next step where we are going to create what? We are going to create band composites. Is that fine?
Yes.
Perfect. So there are two ways you can create composites. The first way is to click properties of that raster. So when you click the properties, you'll come to symbology. Then you'll have the red, the green band, and the blue band. Now it's up to you to play around with what you want to be in the red band. Remember, we stacked 4 bands in the order: band 1, band 2, band 3, and band 4. So we have band 1, band 2, band 3, and band 4 in that order. So if you want to have to visualize a true color composite, I just have to visualize it as 4, 3, and 2. Then I click apply. So as you see, this is a true color composite. So if I want to visualize a false color composite, still I can come here, properties, then I want to visualize maybe 3, 2, 1, then I apply. And of course, it depends on the number of bands you are using. Remember me, I just selected 4 bands for demonstration purposes. But assume we had a stack of 12 bands and whatever classification we wanted to come up with, we could play around with whatever false color or true color composite we would want to do what? To make. But of course, these guys who made the SCP plugin tried to simplify things. For them, they said, you know, you don't have to always waste your time doing that and that and that. You see this RGB thing here? So you just come here and then use the bands you've created in the stack to visualize an RGB. So if you want to visualize an RGB, I'll try 4, 3, 2, and then I click enter. When I click enter, a new virtual band set will be opened. As you see, this is 432. Okay, if I want to visualize another what, I can visualize 321. You say 321, it's already, it will open within a click of a what? Of a button. But however, to be able to do this, you should have in mind the way your bands have been organized. If your blue band is 3, if your blue band is 4, then you may have to play around with this what? With this platform or this RGB thing to get the best results. So me, I'll leave it as 4, 3, and 2. So it is what? It's a blue color composite. Should we continue?
Yes, please.
So we've seen downloading satellite image array, we've seen installing the SCP plugin, and then we've worked with the spatial subset, and then we've managed to mosaic our image, and then we've created what? Color composite. Then I want us to dive into unsupervised what? Classification. So maybe from our lecture, we saw that unsupervised classification deals with clusters. And then from those clusters, you can get classes out of the clusters. So before you do unsupervised classification, you should always have in mind that how many clusters do I need? And then after selecting the clusters, you move from clusters to classes. So to do unsupervised classification, it is very simple here. Still, you come to the SCP plugin, and then you come to band processing. And then you come to what? To clustering. So when you come to clustering, of course, remember we created already a subset, and we only have that one subset. So when you come to that clustering, you can have a number of methods. We have k-means, and then we have isodata. And I know Prof covered this in the class, so I will not labor going through k-means or isodata. Yeah, for this demonstration, I'm going to use k-means. So this number of classes are the number of clusters. So you can decide to leave them as 10, and then after it has finished creating those clusters, you can reclassify and get like how many classes, whatever classes you need. Remember, we move from clusters to classes. So, and then of course here we have the maximum number of iterations. This is the time the algorithm will iterate to look for the what? For the clusters. So me, I always leave them as 10, but for demonstration, I'm going, just allow me to reduce them to 5 because the 10 will take a lot of time. Let me just put them as 5. But if you are doing your analysis, you can always leave them at 10 or even more than 10, you know? Yeah. So let me use 5. The iterations, the number of iterations. So since I'm not using isodata, these ones I'll not use them, and then use the node after value as 0. And then the rest, I leave them as what? As default. And then I'll click here, run. When I click run, still the algorithm will prompt me to select where to save my what? My file. So I create here a new folder, and then I call it unsupervised. So, and then I will select it. And then inside there, I'll save my file as classification1.tif. Then I save it. So as you see here, the plugin will give you the progress. It will start by calculating it will start by defining the clusters. And then after defining the clusters, it will iterate the first what? The first time. And then it will carry out a classification. I see it is iterating the first time. And then after that, it will do it the second time. And it will iterate up to the number of times you've done what? You've selected. I hope that is fine. Maybe as it is iterating, I can handle a few questions so that as soon as it finishes, we dive into what? Our tutorial again. Do we have any questions, please?
Excuse me.
Yes, please.
What was the importance of considering the coastal area, so band 1? Have we used it per se?
Yes,
And-
please, we have. We have. So remember when we are classifying, okay, let us go back to first principles. Remember, if we are doing a classification and we have one band, like one band, any band, band 1, band 2, band 3, band 4, we cannot easily separate our classes, or the separability between our classes is not that good. So it's not always a matter of fact that the number of bands you have is the better the separability, but at least since you have different number of bands, then at least the separability of your classes or clusters in each band will be better than if you had what? 1 or 2 bands. So that's why I've included the coastal aerosol band in our class, in our classes, in our layers, so that during our classification, we can use it. Is that fine?
Yes, thank you. There's a question in the chat.
Okay. How does the number of iterations improve the quality of the output? Yes, it does, because remember, at each iteration we are computing, okay, the software is computing the center of the what? Of the cluster, because we don't have classes yet. So it's not always a matter of fact that the more the clusters, the better the classification. But from experience, I will tell you that, for example, you see this product, I've used 5 iterations, but it's not the best it could be. If I had time and I ran the one for 10 class, if I had time to run using a value of 10, you'll see that the more we give this algorithm time to decide and iterate, this class, then it will iterate another time and another time. Maybe to conclude this, assume we only iterated 1 time. So the first time you iterate and then it gives you your classes. That means we've not even given the algorithm a chance to explore various possibilities of where to do what? To have our clusters or each pixel to belong to. So it's not always true that the more the more the number of iterations, the higher, but as a matter of fact, a few iterations will not always give you the best results. Yeah, I hope that is fine. Should we continue?
Yes.
Yes. Okay, thank you. So this is our product. So this is our product. But of course, remember we had 10 classes. So this is class 1. I'll open the properties. So when I open the properties, I can see the what? The classified outputs. So the first thing that I'm going to do to define clusters or classes is to compare this to this. Remember, I have this, the true color what? composite. And then I have my classification. Now it's up to me to look at this, and then I say, what is this? And then I assign a class to what? To it. And then I assign an appropriate what? Color to this. So, and as you see, when you look at this green, this area here, this is water. You see? This is water. So I'll come this, I'll click properties, and then I know that this is water. So why can't I give it a blue color? Then I give it a blue color. Then I click apply, then okay. Oh, a moment. I gave a wrong one. So this is water. If this is my water, yeah. But of course, this classification is not the best, as I told you, because in order to save time, I selected what? A few iterations. And now it is costing me, you see? Because of the few iterations, this algorithm has not been able to distinguish between this green and the water. Remember, we have wetlands here, we have the water, and then we have other vegetation. I'm very sure if I had specified in what more iterations, we would have achieved a better separation of these classes. Yeah. So let me hope someone who asked that question is now following. Yeah. So assuming this was all water, and then okay. Still, you see this red, you see this blue. It has not actually achieved the best separation between these these classes. Yeah. So, but when you compare your classification, the unsupervised classification, and the true color composite, you can actually get classes, and then from those classes, you reclassify your classified data from 10 classes to the number of classes, from 10 clusters to the number of classes you do what you want. Let me say from this, we have 10 clusters. So it's up to you to determine like 5 classes or whatever classes you want. And then you just compare and see, where does this belong? Where does this belong? And then you do what? You reclassify it into another another class. I hope that is fine. Are we at the same page here? Yes, please. Are we at the same page?
Yes, please.
Thank you. So I'll just leave this as an assignment to you to go back and try to look at the effect of the number of iterations to the quality of the classification, because I don't want to continue with this because it is not that good, but at least I've managed to demonstrate to you how you can do this. So let me now go into supervised classification. Now, with supervised classification, remember that we have a few things to consider. The first one is the classification scheme. Remember, a classification scheme will have the number of the classes that you want to identify from your image. So maybe you want to identify water, you want to identify vegetation, you want to identify the build-up, you want to identify the wetland and other things. Then it's up to that classification scheme to guide you on how you are going to do that classification. So to do the supervised classification, you will come here to view, and then you come here to panels, and then you click here, SCP doc. When you click SCP dock, it will have a path to dock this SCP plugin here, so that we can use it in our what? In our classification, or the supervised classification. So the first thing that I'm going to do is I'm going to look at my image like this. When I look at it, I can select a number of classes I want. So for me, for today, for demonstration, I'll select, this is class 1 water. Then I'm going to select the built up as the second class. I'm going to select this dark green as vegetation class, the one vegetation class. And then I'll select this as another vegetation class. Let me just take those 4 classes since we don't have a lot of time. Yeah. So I'll just come here to ROI options. Now I'm using my what? My display. So I'll come here to my training input. So a few things that I want to take here. For the training input, maybe you've used QGIS, you've used ADAS, maybe you've used, what is this other software? Envy. So each software will have a way it handles things. So, but for QGIS, it is quite simple. We have the MCID. MCID is a macro class ID, like macro to mean big. And then MC name is the macro class name. And then CID is the class ID, and then CNAME is the class name. What does it mean? For example, I may have a bigger class as water, but then inside that water, I may have a smaller class that is river, and then I have lakes, and then I have streams. So if I'm defining my training data, I can micro class ID of 1 and a micro class name of sample of the training classes. I use a different class name and class ID to select them. But if you don't want to distinguish between that, you can only use the general classes. Water is water. Buildings are buildings. Vegetation is vegetation. Yeah. So I'm going to do, I'll come here and then I create a new training what? Input. So I'll click that and then it will prompt me to save my what? My new training data file. So if you use QGIS, QGIS uses it is called the signature file. So it's like creating signatures for training. Yeah. So let me call it train data. So I call it train data. I'll come here and then I call it still train data. Then I save. So when I save it, the path can be seen here. So to add a new sample, I'll zoom to where I want to add it. And then I come here. You see this what? So this is also part of the plugin. When you activate the plugin, this one will also be enabled in your what? In your browser. So I'll come here to create a region of interest polygon. So I will draw it here. Just draw it the normal way we digitize, then you do what? You press your left click, actually right click, and then it will finish. Then my macro class ID is 1. My name, I can call that water. Maybe I can add one more, like here. Still, let me add one more. Yeah, so those are 2. So I can call that water. To save, I click this, you see this button, and then I'll save it. So it will create the ROI and then it will compute the what? The signature. As you see, it's calculating the signature. The same way QGIS calculates the signature files. Yeah. And then after, of course, it doesn't take long. It takes a little time. Again, yeah, it finishes. So I'll come here and I change this color to blue because it is water. So again, I will come here and I add a new what? Remember this, the class ID and then the class name. So I'm done with water for today. Then my second class ID, the macro is going to be the buildings. Let me call them buildings. Yeah. So when I call the buildings, still I can even call them buildings here. Doesn't do any harm. Or you can call them houses, whatever, depending on your classification scheme. So I can come here and select a few pixels like this. I can also select another pixel. And I can select this. Yeah, let me just use those two. Then still I save them. So when I click save, still it will compute the signature file and then it will save my what? My class. So these houses, I'm going to give them red. No, red. So now let me also show you this. If I want to delete this class, I select it and then I do what? I delete it like this. Yeah, it's no longer there. So let me add it again. Let me add it again. Yeah, so I'll save it. Oh, I don't know why. Now let me create these training samples very fast and then we can dive into the what? The classification. So let me, yeah, so I've finished selecting my what? My classes. So the first thing that you can do is to give these classes what? Like the symbology, the appropriate what? Symbology. Give this green. So then after you come here where you have the signatures, what? To plot the signatures. So I can select my water class, my building class, this vegetation class, and then I plot them on a signature what? File. So like here. So as you see from this, I can be able actually to see how I like to use how my samples I can be able to see the signature of my what? My samples, as you see here. So this means I've poorly selected my trading samples because you see here, I've put 2, but then for the signature, I can only see, I've put 3, but for the signature, I can only see 2. Then that means I have to select my samples very well, so that I can even come here and I see how separable they are. Can even come here and see the details, you know, and then you do more and more what? Analysis about your data. So what I'm going to do, that I'm going to clear all this. Then let me do this quickly. Class ID 1, it will be water 1. I'm just trying to create new class and just trying to create new training samples such that I can show you how separable my classes are going to be. This will be class ID 2. Then it will be buildings. And I will add it. So for demonstration, I can use this. So I've already shown you how you can plot this. How you can plot this. Yeah, and of course, I will not expect very good results since my separability is not that good as you see here. You can actually play around with this and then, yeah. So now what I'm going to do is that I link here to the SCP, then I come to band processing, and then I'll come to what? Classification. So when I come to classification, there are a number of what? There are a few options actually. Remember here we have the macro class ID and the single class ID. So for classification, you can select the macro class ID or the class ID, the smaller class inside the macro class. So me, I'm going to select the macro class ID, and then I will classify the other band set is band 1, the one we made at the start. Then the algorithm, you can use maximum likelihood, spectral angle mapping, or minimum distance. But remember, minimum distance is not that what? That good. So let me use maximum likelihood. And then the rest, I'll leave them as default. Yeah. But before I do that, I can choose to have a look at how my results will be before further running them. So to do that, I will come here. You see this? I will activate the classification preview pointer. Then when I activate it, I can just click anywhere. Oh, the following signature has not a covariance matrix. Yeah, I know. Okay. These signature files have a problem, but allow me, since I've shown you everything, allow me import. I'm just going to import a new signature file I already created, and then I also import that data, and then I just take you through the classification. Chop, chop. So I'll just click here and then I open a new train. Yeah, this one, this is what I've been. Okay. moment. Moment, I'm just creating these training data very fast so that I can show you how my product will look like. Yeah, then I can finish this. So I'm back. I've created 4 samples, 4 classes: water, building, vegetation, and wetland. So I'll just come here to SCP, then band processing, then classification. And when I click classification, like as I told you, I'll use maximum class ID, MC, macro class ID. Yeah, and then to see how my results will look like, I'll just activate this classification point, what? Preview. And then when I click it, it can show me how my results are going to look like you see here, like you see. So depending on that, I can choose either to select more classes or to proceed with my what? With my classification. The beauty about this is that before you dive in further, you know that no, my results are not that good. Yeah, I need to improve my what? My classes. And then you improve your classes. And then also remember that I had showed you about this tool where you can select your samples and then plot them on a what? On a graph, and then actually be able to see how separable they are going to be. Yeah, but let me proceed, and then I classify, and then I show you by what? So to classify, I'll just come here, and then I click run. That's all. Then run, of course, I'll save it in a given folder as supervised classification. Yeah. When I click supervised classification, it will actually, after saving that, it will just run, and then it will give me what? A product. Just a few, yeah, then it's done. So this is my classification. Hope you can see it. Like it, we have the water, the blue is water, then we have the wetland, this, then we have the built up, and then we have the vegetation. Of course, you can improve this classification and make it better and better and actually best. How can you? You just have to make sure that you study the imagery you have. You just have to make sure that you select the appropriate training samples and select them in what? In good numbers. By doing that, you'll be able to achieve the best classification you can. I think for today, allow me to stop here. Maybe if there is any question, I can handle it. Thank you so much.
Angela, please ask the question you have.
Yeah, excuse me, Jesse. I wanted to ask you, like for the 2 classifications.
Yes, please.
Which one is the best, like between the supervised, or in which scenarios can one use the supervised or the unsupervised classification, or which application would be best for the 2? Any you can answer. Thank you.
For sure, I don't want to lie to you. The last time I did unsupervised classification was in school. Yeah, because most times when you are dealing with a real life project, you will be interested in a given number of classes. Maybe you want roads, you want buildings, you want what. So you will go and pick those classes by yourself, and then determine and then do the what? The classification. For sure, since school, I've never done any unsupervised classification. But on the other hand, it's like even every day we do what? We do supervised classification. For most of the projects I've been doing supervised. So when is it appropriate to use unsupervised? For sure, I don't know. Maybe Prof can answer that. So someone is asking, then how to handle the accuracy assessment? Yes, accuracy assessment you can handle but I can't show it today, but you can handle and then create the confusion matrix. And then you do what? You analyze the confusion matrix. But since our time is fast spent, it's now 7. We can't do that. We can't do that. But then I have a YouTube channel here. I will do the accuracy assessment on that YouTube channel, and then I share the tutorial. As soon as I share it, I'll just tap you, and then you can go there and do the accuracy assessment from there. Thank you. Any other question, please?
Okay, thank you very much. Jesse, maybe you can share the link to your YouTube channel in the chat so that they can use it.
Let me share it, Prof.
And about unsupervised classification, we usually use it for preliminary work. Let's say you are going to have a mapping expedition, you are not sure of the classes, you do unsupervised, then you go to the field, you collect your data, you see your classes, you come back, and that can help you do a better supervised classification. So that is an example of how we can use unsupervised classification. Otherwise, thank you very much. Jesse, have you shared?
Let me share it now. I had not yet. Let me share it in the chat here.
Doctor, we also need the notes.
The notes for what? The slides, you mean?
Yes, the slides, sorry.
That one you talk to Jesse. He's the one presenting. So talk to him properly.
Jesse, can you
But Prof, there are no slides here.
What you show.
No slides here.
I think if you have the recording, that should be good enough. Don't you think so, Helen?
Okay, Professor.
Yeah.
Anyway, I'll share the slides, but how? But anyway, these are, anyway, let me just share them, Prof. Oh,
Yeah.
I
So,
forgot to tell you, merci beaucoup.
Okay. Thank you very much, Jesse. I hope class you have seen, got a flavor of how we can do what we have been teaching. You have, when we talk of bands, you know what that means. And yesterday you got to see about thermal remote sensing. So tomorrow we shall be having, I'm inviting another former student of mine who will describe a real life project, just as said, he does these things for various projects. So I've invited somebody to come and describe the project that they have worked on, and you'll see how all of this can be used to address, a real life concern. And hopefully this will tease your interest in applying remote sensing in whatever application areas of your choice. Any questions before Jesse goes? Helen, I think you should get in touch with Jesse for the slides because I don't have them. So you might have to DM him to get the slides.
Jesse, can I share my email on the chat box?
No worries. No worries.
Okay.
Yeah. Thank you so much, Helen. Let me send the slide as soon as possible.
Consider the second email, kindly.
Thank you so much, guys. Wish you the best. Merci beaucoup.
Thank you very much.